Imagine a cosmic explosion so powerful that it outshines everything else in the sky. A burst of gamma rays so intense that it blows away all other celestial events. That's exactly what happened on October 9th, 2022, when astronomers detected the brightest gamma ray burst, GRB, ever observed since the Big Bang itself. This extraordinary event, known as GRB 220109A, or the brightest of all time, has shattered records and provided unprecedented insights into the most energetic phenomena in the universe. Hey everyone, welcome back to Physics Space. Today, we're diving into an astronomical phenomenon that has left scientists and space enthusiasts absolutely astounded. We're talking about the brightest of all time, or BOAT. Specifically, the gamma ray burst known as GRB 220109A. This explosion is not just any cosmic event, it's the brightest explosion we've seen since the Big Bang. So buckle up as we explore what makes this event so extraordinary. First, let's understand what a gamma ray burst is. Gamma ray bursts, or GRBs, are extremely energetic explosions that occur in distant galaxies. They release a tremendous amount of energy in the form of gamma rays, which are the highest energy form of light. These bursts can last from a few milliseconds to several minutes and are often associated with the death of massive stars. Imagine the energy output of a typical star, but concentrated into a fraction of a second. That's what a gamma ray burst is like. On October 9th, 2022, astronomers detected GRB 220109A, which quickly became known as the BOAT. This gamma ray burst was observed from a staggering distance of about 2.4 billion light-years away in the constellation Sagitta. What's remarkable that this event was so bright, it outshone everything else in the sky. It was about 70 times brighter than any previously recorded GRB. Imagine seeing a light so intense that it drowns out the stars around it. So, what caused this incredible burst? Scientists believe that GRB 220109A resulted from the collapse of a massive star, leading to a supernova explosion. This collapse likely created a black hole, which then released an enormous amount of energy in the form of gamma rays. Typically, we expect such massive explosions to produce heavy elements like gold and platinum. However, the BOAT presented a surprising twist. Despite the expectations, researchers found no evidence of heavy elements in the remnants of GRB 221009A. This finding raises intriguing questions about the processes that occur during such powerful explosions. Why didn't we find these heavy elements? One theory suggests that the explosion's energy was funneled through a narrow relativistic jet, focusing the energy output more effectively than typical GRBs. This could explain the absence of heavy elements, as the conditions were different from what we previously thought. The discovery of the BOAT is significant for several reasons. First, it challenges our understanding of gamma ray bursts and the processes that lead to the formation of heavy elements in the universe. It also provides a unique opportunity for scientists to study the aftermath of such a powerful explosion. Researchers are planning to use the James Webb Space Telescope, or JWST, to study other supernovae and gamma ray bursts. By comparing these events, they hope to gain insights into the conditions under which heavy elements are synthesized. The implications of studying GRB 221009A extend beyond just understanding gamma ray bursts. They could help us learn more about the early universe, the formation of galaxies, and the life cycle of stars. Every discovery leads to more questions, and the BOAT is no exception. As we continue to analyze this event, we may uncover new insights that could reshape our understanding of the cosmos. The afterglow of GRB 221109A has been extensively studied across the electromagnetic spectrum. In the X-ray band, observations by the Chandra X-ray Observatory revealed a bright and long-lasting afterglow. The X-ray afterglow was still detectable more than a year after the burst, making it one of the longest-lived GRB afterglows ever observed. At optical and infrared wavelengths, the afterglow was also exceptionally bright, allowing for detailed spectroscopic observations with large ground-based telescopes like Keck and the Very Large Telescope. These observations provided insights into the chemical composition and physical conditions of the material along the line of sight to the burst. Implications for jet structure. The long-lasting and slowly fading afterglow of GRB 221009A has important implications for the structure of the relativistic jet that produced the burst. Typical GRB jets are thought to have a sharp edge, like a searchlight beam. However, the observed afterglow of GRB 22109A suggests a more gradual decrease in jet energy with angle from the jet axis, similar to a lighthouse beam. This structured jet model can explain the unusually long-lasting afterglow and the lack of a clear jet break in the light curve, which is often seen in GRBs with sharply edged jets. The structured jet likely had a narrow core with high energy output, surrounded by a lower energy wing, which dominated the observed emission at late times. Given the extreme nature of GRB 221009A, it is an important target for searches for associated neutrinos and gravitational waves. Neutrinos could be produced in the jet itself or in the interaction of the jet with the surrounding medium. Gravitational waves could be emitted during the collapse of the massive star progenitor or the formation of the black hole central engine. So far, no definitive neutrino or gravitational wave counterparts have been reported for GRB 221009A. However, the non-detection still provides useful constraints on the properties of the burst and the underlying physical processes. Future observations of similar nearby and energetic bursts will be important for advancing our understanding of the neutrino and gravitational wave emission from GRBs. So there you have it, the brightest of all time. GRB 22109A is not just a cosmic spectacle, it's a key to unlocking some of the universe's greatest mysteries. If you enjoyed this video, don't forget to give it a thumbs up, subscribe for more cosmic content, and let us know in the comments what you think about this incredible explosion. Until next time, keep looking up at the stars.